Hello, we are the EERC 328A Environmental and Power Monitoring Group. I am Alex Light.
I'm Nate Enciso.
And I'm Jacob Mulder. So kind of an introduction to our project and our scope. In ERC room 328A, it's a critical place housing a lot of networking and server infrastructure for the Applied College Computing Department. With that room comes some risks. We need to ensure stay a stable thermal environment. Excessive temperatures and poor airflow can cause problems with hardware efficiency, effectiveness, and like the lifespan of the devices. And so that kind of shows like the necessity for the room. A previous group did come in and work on kind of directing and controlling the temperature in the airflow. But following their project, there was still another need. With that, their solution, while it did effectively deal with some of the thermal side, it lacked proper monitoring, and their the solution wasn't fully up to the needs of the room. So we kind of came in and are working to establish a different monitoring system. We used HomeAssistant, and then we also chose to work on tracking the energy consumption of the room using some Emporia energy monitorings. And we also wanted to implement real-time alerts as well as a physical monitor that people can then see the stats that we're pulling from the room.
So for the central computing, we have a Raspberry Pi 5 that's running our Home Assistant OS as the primary controller. In terms of sensors, we have 7 Akara sensors as well as 4 Adore sensors, which are all integrated using Zigbee protocol. For the energy monitoring, we're using Emporia, which uses CT clamps. And then for our external display, we have a second Raspberry Pi that's configured to display the live dashboard of the statistics we collect. So the system is currently unified into one central location for our monitoring compared to what the previous setup, which was very fragmented. For thermal optimization, we have real-time data analysis, which enables us to identify critical airflow efficiency. An example of this would be reversing the exhaust fan. When we did that, the temperature reduced by about 50 degrees Fahrenheit inside the hot aisle, and that's just one example of the um, monitoring we can do in the room.
So some challenges we had were obviously the previous group mentioned had some fragmented process, so we were working to audit that and migrate that to a new, more stable setup without any loss of functionality. Constraints were we had a strict budget requirement, and we had to specifically avoid any subscription-based software services, and coordinating with university facilities for electrical access. And then for some future development, we hope this provides a foundation for future analysis of the complex airflow patterns and some long-term power saving strategies, as well as the addition of decibel-based noise safety monitoring and the addition of water leak sensors to help provide more relevant alerts. And our acknowledgments are obviously our team, our faculty advisors, Tim Van Wagner and Kevin Myers, institutional support from the College Computing and Department of Applied Computing, and facility support for the staff regarding the electrical panel coordination. Thank you.